This is a screencast for section 6.4, example 4. We're going to convert from rectangular coordinates to polar coordinates. So I am given a rectangular coordinate of -1, 1, and I need to find out what the r and theta would be, and of course there's infinitely many options to that, but the directions ask us for 2 options to give us the same location of a point than on a polar coordinates. So first I'm going to create a visualization of what I'm dealing with. And I'm going to draw a reference triangle, and I'm going to try and figure out what my reference angle is to then give me the correct theta for locating that point in polar coordinates. I can use Pythagorean theorem to find my r value. First of all, the adjacent side here would be -1, the opposite side would be +1. So using Pythagorean theorem, I find out that r equals plus or minus square root 2, which makes sense because I'm going to have 2 different options for polar coordinates. So if r is positive, I'm going to use theta. If r is negative, I can use a different theta that would land my terminal ray in quadrant 4. So to find out what that theta is, or the reference angle, I know the reference angle is opposite over adjacent side. So I'm going to use the inverse tangent of theta equals its opposite over hypotenuse, so 1 over -1. Now remember, the range of inverse tangent is -π/2 to π/2. So I can't use 3π/4 as theta, but I can use -π/4 that lands in quadrant 4 as the solution for my inverse tangent. But that's okay, because if theta is -π/4, that's actually another angle that I can use. So we have all the information we need, we just need to put it together in 2 polar coordinate pairs. So first of all, if theta was -π/4, that means -π/4 is in quadrant 4. The terminal ray would be in quadrant 4. I want the point to be in quadrant 2, so I would use -√2 as one of my options. Now what if r was +√2? Well, that's where I can use π/4 as a reference angle, and then 3π/4 might be an option for one of my other polar coordinate pairs. Now, of course, you may have a different answer depending on what of the infinitely many polar coordinate pairs you chose. Now in part B, the rectangular coordinates are -3, 0. The r value is going to be -3, or 3. Because the distance from the origin of that point is 3. Now I can still use inverse tangent of theta to help me find what theta will be, but I also know that pi radians is where this terminal ray would land, so it's up to you. But if I were going to use inverse tangent, the opposite side would be 0, because the height of that is 0. And then the adjacent side would be -3. So I'm really just looking for the inverse tangent of theta to equal 0. And I know that that would be 0. So I have all the information I need for my 2 polar coordinates. I can use, if r is -3, theta would be 0. 0 is on the positive x-axis, so I would need the r value to go backwards 3. Or I can use, if r was +3, I can use the radian of pi. Then I'll try problem number 27. Asks us to find all polar coordinates of P that satisfy, in this case, P equals 1, 1. So if our rectangular point is 1, 1, I know if I draw my reference triangle, the adjacent side is 1 and the opposite side is 1. Also from Pythagorean theorem, I can tell you that my radius is going to be plus or minus √2. We've already done that. Now, the catch here is find all polar coordinates, which we know are infinitely many, and we've represented those in an expression using n as all real integers. However, this is different because it gives me boundaries for what theta can be. Theta can be between 0 and 2 pi. So first of all, I need to find out whose tangent is 1 over 1. So I'm going to use the inverse tangent of 1. So theta is pi/4. If theta were pi/4, I could use √2 as a positive value because it would go along pi/4's terminal ray. But if r were -√2, I would have to use, again, between 0 and 2 pi, so I'd go all the way around to, let's see, 5π/4. So those are my 2 options between 0 and 2 pi, the only options I have between 0 and 2 pi. Now part B is asking us to find two polar coordinates in between the intervals of negative pi and pi. So I will use square root 2 comma pi over 4 again because pi over 4 is between negative pi and pi. But now the other way I have to go backwards, so my next theta is going to be negative, and that will be 3 pi over 4. Now since that terminal ray would land in quadrant 3, I need r to be negative square root 2. So those are my two options, the only options, between negative pi and pi for theta. Part C is asking us for all options between 0 and 4 pi for theta. So again, I'm going to use, let's see, pi over 4. And strategy-wise, I'll just keep going around the coordinate plane and labeling all of my thetas that I can use and find out what r values need to go with those. So pi over 4, keep going around, that would be 5 pi over 4. Keep going around, now I'm at a terminal ray, or excuse me, coterminal ray of pi over 4. So let's see, pi over 4 plus 2 pi would be 9 pi over 4. And then again, I'd be at a coterminal ray of 5 pi over 4, so 13 pi over 4. So pi over 4 lands in quadrant 1, I can use positive square root 2. Same with 9 pi over 4. But 5 pi over 4 lands, the terminal ray lands in quadrant 3, so I have to use negative square root 2 in both 5 pi over 4 and 13 pi over 4's coordinates.